Hello, I'm Lewis and this is DIY Machines, the channel where I get to show you step by step how to 3D print and assemble awesome projects. Today we're going to be recycling these old used filament spools into a smart ESP32 powered low-cost lamp. Now over time I have collected a fair few empty filament spools, and they always just seemed too good to send straight to recycling. A filament spool lamp isn't an entirely new idea, but I wanted to add some new features to these. We can add an ESP32 along with a digital microphone, which will allow us to have these really cool sound synced shiny shows. This will also provide us with a means for MQTT, Philips Hue and Amazon Alexa integrations. Naturally, all of this can be controlled from any device over Wi-Fi using the device's own web interface or any of the free WLED apps. Though sometimes it's easier to just adjust the brightness without using an app or computer. For moments like this, I've integrated a dial on the top which allows you to instantly and conveniently adjust the brightness. I've also integrated a discrete button on the underside of the lamp. A short press changes the lighting pattern, and whenever the mood takes you, a long press of this discrete button sets your lamp into its sound reactive mode. I'll also show you 3 different ways that you can deal with the power cable. Clip it to the underside of the lamp. Simply leave it dangling underneath. Or my favourite, conceal it inside one of the legs. This video has been sponsored by PCBWay. I'll tell you some more about them later on. Now, you may be thinking quite correctly that filament spools come in all sorts of different shapes and sizes, mostly circular, which is why I've created a Fusion 360 model which you can adjust using a table of parametric values. This will update all the 3D printable parts to suit your spool. You can then download these and 3D print them. I've written out full instructions on how to update the Fusion 360 model, and you can download it as well from my website freely. So hop over there, get your 3D printed files customized for your lamp, and then you can follow the rest of this video for the assembly instructions. Now this project is a simpler build, so you'll only need a few components to complete one of your own. You're going to need an ESP32 development board, microphone, logic level shifter, a DC buck converter, 5K potentiometer, tactile button and 1K resistor, a DC barrel connector and some addressable 12 volt LEDs, a 12 volt power supply for those LEDs and some 3D printing filament. You'll also need some material to use for the legs of your lamp. I'm using some broom handles, and of course you're also going to need those empty filament spools, which is what we're recycling in this project. And I've also put together some of these electrical kits on my international Etsy shop. Each kit purchased helps fund the next project. Thank you. The very first part that we can print are the feet, which go on the end of our legs. I've printed mine in PLA filament, and you'll need to print yourself 3 of them. Now, if one of the legs that you'll be printing is going to conceal the power cable inside, then you should make one of your feet one of the ones with the hole. This is so the wire can pass into the leg discreetly. Whilst they print, you can cut the leg itself down to whatever size you prefer. Shorter lengths can make for a pleasing table lamp, whereas longer lengths can make for a more striking floor lamp. You can also use a variety of materials. I use wooden broom handles, you can use wooden dowel rods, clear acrylic tubes, PVC piping, or anything else you can think of. If you want to conceal your power cable, you're going to need to create a rebate in one of the wooden legs. You could create a temporary jig out of some scrap wood to hold an oversized leg while screwing it on with great care on a saw. Or, as I did for my desktop lamp, 3D print some end holders and have a CNC machine route them through the center line. I used my snap maker for this. It's inside this rebate that we will conceal our power cable. I'm going to be using some hot melt glue to attach my 3D printed feet to the ends of my wooden legs. It doesn't need to be a particularly strong glue, as we'll have gravity on our side keeping these two parts together. If you're using a natural material such as wood, pay attention to any blemishes that you might find on the leg and turn these towards the inside of your lamp where they're less likely to be noticed. If you're going to conceal your power cable inside the special foot, then feed the wire through the foot first before fixing it in place into your leg. You're going to need at least 15 centimeters of free wire at the open end of the leg. We'll trim this down to a more suitable size later. Next up, we can 3D print the base of our lamp. I recommend choosing a concentric infill on your slicer, which should improve the finished appearance of our print. This is also the only part which will require supports to be enabled. Glue this to the legs, ensuring you keep everything level as you go. I'm using hot melt glue again, as it'll allow me to make adjustments later when leveling out the lamp. You should also make sure that each of your 3 feet are correctly rotated, so that they sit nice and level on the surface. If you are concealing your wire inside one of your legs, then this leg should be inserted in the leg hole, which has a hole passing through to the other side of the base of our lamp. That's this one. If you're going to use a barrel connector to connect your electricity supply, then attach this now. So I've decided to use the concealed wiring method for my tabletop lamp. It doesn't matter if you're going to use the barrel connector or conceal your own wires, the wiring from here on will be the same. So I'm going to remove this in a second. Let's set our base aside for a short while and we'll start to work on the main shade of the project. Now we can begin preparing some of the LEDs for our project. Now the WS2811 LEDs, which we are using, can only be cut at certain points every 3 LEDs. This is marked on the strip by this line here. You'll also notice these arrows on the LED strip showing how the data flows from one group of LEDs to the next. When we rejoin our LEDs later in the circuit design, you'll need to make sure that these arrows are consistently pointing in the same direction through our circuit away from the PCB. Don't worry though, I will remind you again later. Power, on the other hand, can flow in both directions. Wrap a length of your LEDs around the spool and then cut at the line you think is best. I'm going for a slight overlap. You should try to cut as close as you can through the center of the copper pads. This is so that you have a good amount of copper pads on either side to solder your wires onto later. And don't worry if where you want to make your cut you already see some soldering. You can cut straight through these and it will save you some tinning later on. cut some more strips the same length for each of your spools. I'm using 3 spools on my tabletop lamp, so I'll cut 3 lengths. So the next thing that we should do is tin the ends of our LED strips. This simply means adding some little blobs of solder to the copper pads at the ends. Do the same to the cut ends of your wires, and then when we come to join them together, you're going to find it much more easy. For the wires between the LEDs, you'll need a set of 3 about 13 centimeters in length for each spool you are using. For my 3 spools, that's 3 sets of 3 wires. Add a set of 3 wires to both ends of your first LED strip. If you're only using 1 filament spool in your lamp, then just add the 3 wires to the incoming side of your LEDs. Solder each of your remaining sets of 13 centimeter long wires to the outgoing end of your remaining LED strips. This will leave you with 1 strip with no wires. So now we can attach our first LED strip, that's the one with wires at both ends, to our first spool. I found that the self-adhesive backing already on my LEDs was sticky enough to hold them in place for me. You're then going to need to thread the wires through the center of your spool so that we can pass it up and down inside our lamp. Handily for me, my spool has these little holes here which gives me access to this section, so I'm going to use this to thread my wires through. If your spool does not, then you should probably drill a hole into the center section of your spool, and do this to all your other spools now whilst you have your drill out. We can now take our next empty filament spool and thread the wires from the outgoing end of our LED strip through the center of this second spool. To join each of our spools tightly together as we stack them on top of one another, you can choose between either a chemical or mechanical fixing, such as nuts and bolts. I'm taking the chemical route and will be using some of Loctite's all plastics superglue, which is rated to work with polystyrene, which is what the spools I'm using are made from. Once applied, I used as many clamps as I could lay my hands on to help ensure that the seam between the 2 spools is as tightly fitted as possible. So this is a great time for me to grab a cup of tea and say thank you to my patrons who helped make this project and video possible. That's this list of super amazing people going past now. I also want to say thank you to 3D Jake, who provided me with the filament and of course the old printing spools from previous projects, and PCB Way, who have helped me with the PCBs and electronics. Now, if you'd like to join these amazing people in helping make future projects possible, then please consider having a look at my Patreon page or my YouTube memberships. With either of these services, you're going to be able to see exclusively what I'm up to behind the scenes, how the next project is progressing, and get access to videos just like this one before anyone else. Now that the glue has had a few minutes to cure, we can remove the clamps from the spool and solder our next length of LEDs, this is another one with the wire attached, to the outgoing end of the previous LED strip. These LEDs can then be attached to the spindle of the second spool, ensuring the start of this strip is aligned with your previous strip. We can then continue adding spools and LEDs all the way up to your last spool, which will use the LED strip with no wires pre-attached to it. So before we tidy our loose wires, it would be a good idea to continue with the electronics and check that everything works first. So the next thing we'll do is take our ESP32 and program it. The easiest way to do this is to open the Chrome web browser on your computer and navigate to install.wled.me. Now, the version of WLED you install depends on how you want to use your lamp once you've finished building it. There are two main versions here. The sound reactive one will work with our digital microphone to allow you to sync your beats with the music. It's a really cool feature and it's what I'm going to go for. The more standard version of WLED allows it to connect to services such as Alexa and Philips Hue and MQTT servers. However, this comes at not being able to use the sound reactive features. Perhaps in the future, both versions will merge into one common installation, but for now, you'll need to choose one or the other. Once you have chosen your version of WLED, go ahead and press install. You'll then choose your serial port for your ESP32. Press install and you'll see a warning. Before you confirm the install command, hold down the boot button on your ESP module. We can then proceed with installing. When it gets to the point of erasing, you can release the boot button and wait for it to complete its installation. When it has completed, go ahead and enter your Wi-Fi credentials on this screen. After it has saved and WLED has connected to your Wi-Fi, choose to visit device. Take a note of the IP address shown in your browser as we're going to need to use this later. Let's switch our soldering iron on and begin soldering components to our PCB. None of this is tricky soldering, so I'll guide you through it now, step by step. I designed a custom PCB to make everything very easy to assemble. It drastically cuts down on wiring and holds everything in just the right place. Of course, if you don't want to use a PCB, then you'll find a link to a circuit diagram down below so you can design your own circuit for your project. There, you'll also find links to all these individual components on Amazon. Our first component is going to be this tiny resistor. Just simply insert its two legs through the holes on your PCB and solder in place from the other side. Our logic level converter is next. You'll need to align this small notch on the chip to the same markings as illustrated on your PCB. You can then insert the feet and solder from the other side again. Our digital microphone is attached in the same fashion, with the text labels found on both PCBs matching. The ESP32 microcontroller is added with its USB port facing outwards to make future updates easier for us. Turning to our DC buck converter next, we need to first configure it to output 5 volts from the 12 volts we're supplying our project with. This is needed to power the ESP32 and to set the signaling logic level for our LEDs. To do this, connect it to a 12 volt power supply on the 2 in pins, and then on the out pins connect a multimeter. Set your multimeter to monitor voltages. I set mine to 20 volts max, and then turn this small potentiometer with a screwdriver until you're outputting just over 5 volts. That's it. Let's add it to the PCB. We can then solder our DC buck converter to the PCB whilst taking care to match the positive and negative inputs and outputs. The 12mm high tactile button is installed with the outward bowing sides of the device aligning with the top and bottom of the PCB. For the potentiometer, which is going to help us control the brightness manually using a dial we'll add to the top later, we need to prepare 3 lengths of wires. Now your wires need to be the same length as your stack of spools is in height, plus an additional 20 centimeters. We can then solder these onto the reverse side of our PCB, and then the other ends of these wires will be attached to our potentiometer. Pay attention that the center wire as marked on the PCB goes to the center wire on the potentiometer. The left and right ones don't really matter, they're just going to affect which way your dial is going to be turned to increase the brightness of your lamp and decrease the brightness of your lamp. We can now connect our power wires. These are the ones coming from either the barrel connector or the concealed wires inside one of the legs. Like the potentiometer's wires, these are inserted from the rear of the PCB and soldered on the front side. Be sure to double check you have the positive and negative wires the correct way around. Then alongside these wires, we can also connect the power wires coming from our string of LEDs. Finally, the data wire for the LEDs is connected to this hole at the top. Before we screw the PCB in place, you should pass your potentiometer through the center of your lamp. We can then take your 3 M3x8 screws to hold the PCB in position. Let's power on our lamp and test it whilst we can still easily see our LEDs. Once you've applied power, your lights should light up. Now, there are quite a few settings to change for our lamp as it's been built, and I've already pre-saved a WLED configuration file which we'll upload to this now, which will configure most of the settings for you automatically. Use a browser to navigate to the IP address which we saved earlier. Open the config menu and then click Security and Updates. Scroll down and then select Choose File under the Backup Configuration heading. Select the config file and upload it. You can download this file using the links below the video. Once these settings have been applied, we can go back to the main screen and test different colors to confirm that our settings have indeed been applied correctly. There are a couple more settings that we're going to tweak in the config page under LED preferences. What you put in here is unique to your build, which is why I couldn't include it in the pre-configured configuration file for you. The first one is changing the strip or panel dropdown to a 2D matrix panel. Now for the width, you need to enter how many of these black little ICs you find going around just one of your spools. And the height, well, that's how many spools you've included in your lamp. Scrolling further down this page, we also need to tell it the total number of LEDs in our project. To do this, just multiply the 2 numbers we added up earlier, 7 and 3 in my case, and pop this in here. For me, that's 21. You can then press save and exit this menu. From here, you can practice altering the brightness of your LEDs from the slider at the top and changing the color using this color wheel. Now, using the potentiometer that you've added to your lamp, you should be able to adjust the brightness by turning it in one direction or the other. Now, a short press of your button should start the lamp to flow through some colors. And if you've opted to add the sound reactivity to your lamp, then a press and hold of the button for just over 2 seconds will set the lamp to its sound reactive pattern. Make some noise, and if the lamp reacts, we'll know our microphone and software is all correctly set up. We can now insert our potentiometer into the top of our spool. Use the bolt that was supplied with your potentiometer to fix it in place. And when you do this, ensure that the wires coming to your potentiometer are moved away from this hole. I'll show you why shortly. You can then fix this in place with its supplied nut, and then on top of this we can install the 3D printed dial. Make sure to line up the 3D printed line with the notch in the potentiometer. This helps give it a good grip as we spin it round later. Now our dial is a little bit wobbly in this example, so to solve that we can pop it out by pushing a screwdriver through that hole that we kept clear earlier, removing the potentiometer, and then using some washes before we put it back into our 3D print to space it a little bit further away. Then once you've assembled this again, you should find that your dial sits closer to the surface and wobbles much less. Once you're happy with this, apply some glue and fix this firmly into place. Whilst we leave that glue to cure, we can go ahead and start printing the diffusers for our lamp. I recommend that you try a few different filaments to find the best one for diffusing your LEDs. You're going to need to print one for each of the spools you are using. Once the glue at the top of our lamp has dried and we can have the use of our clamps again, we can set about gluing the base to our spools. Just make sure when you close these two together that none of your wires become trapped between the bottom spool and the top of your base. Once the glue has cured again, we can take our diffusers and gently bend them into position around each of our spools. You can use some glue to keep yours in position if required. I just added some down the seams on the back here to help hold the overlap tightly together. Now, if you decided to use the barrel connector for your power supply instead of concealing the wire inside one of the legs, then you're going to have a wire dangling from underneath your lamp. This is why I used a white wire in this, because it blends in with the white 3D printed parts. You can also, however, print some of these cable clips, which are part of the Fusion 360 model, and will change their size depending on the dimension of your legs. These can be used to clip the cable alongside one of the legs and keep the overall look a little tidier if you prefer it that way. Now that you're finished, it's time to enjoy your own made upcycled smart lamp. If you're looking for some more instructions on the MQTT, Amazon Alexa and Philips Hue integrations, then you'll find a link below this video to WLED's website, where they keep their documentation for these integrations up to date. Over on my website, you'll also find some written instructions explaining how to reprogram the button on the underside of the lamp to do what you would like it to do, as opposed to the standard features. And there are also some detailed instructions on updating the Fusion 360 file to suit your filament spool size and the diameter of the legs which you've chosen to use in your lamp. If you haven't subscribed yet, it would mean a great deal to me if you did, and share this project with anyone else you think may find this useful. Take a look at some of my other projects. I recently did some 3D printable desktop neon signs, which are quite similar to this project, and the predecessor to this, my GeoLeaf geometric light panels. Thanks again for watching to the end. Until the next project, do some good, and ciao for now. Thank you to PCBWay for sponsoring this project. Now, I was very afraid of creating my own PCBs for my DIY projects, but after following a short tutorial on the internet, which I've linked down below, I started creating my own PCBs and really haven't looked back. In the description below is a link to where you can order this design direct from the projects page on PCBWay's website. I've already preloaded all of the design and settings for you. If you're a new customer to PCBWay, they also have a promotion where you can get $5 towards your first order. And As a set of 5 PCBs for this project only costs $5 at the moment, you effectively only need to pay for the shipping. They also have delivery options starting from as little as $8, or if you're in a hurry, try their express DHL shipping. Once, a set of PCBs I ordered on Monday were on my desk by Friday morning, which is pretty impressive. To using yours, the electronic this simply means adding some little blobs of solder